Hello and welcome to POcast. I'm really excited to have you here. This section I'm going to help you understand a very important topic in PO, and that is XML. XML is a language and PO uses this language a lot for message representation purpose. If you are completely new to this XML and never heard of it or have some prior knowledge, then it's a good news. How? Because I'm going to explain this session with the same understanding and from scratch. One request though. Please do not skip this lesson if you don't know much about XML. You can always fast forward the known topics, but don't skip the entire lesson. If you're a pro and already know about XML inside out, then you get the right to skip it. Let's look at the topics. The topics that I will cover in this section are what is XML and how it is used, understand the terminology, how to read this language. Actually, it is similar to learning a new language like Spanish. So I'll introduce you to a new lingo, which is XML lingo. How XMLs are structured and what are the standards. Then we deep dive into XML namespace and XML tree with live examples. Finally, we will create an XML file, then we will view it in the Chrome. Then I'll show you how to check if the XML is well formatted, valid and invalid XML. I believe always that XML basics should be very strong, so that when you learn another new language similar to XML, you should grasp them faster. So let's learn and start building our own XML files. First, let's look at what XML stands for. X, M and L. Then we will go into details of it. The XML stands for Extensible Markup Language. X in XML is extensible, which means extend your notion. Whatever idea that you have about the content, you can extend it. M means markup. Define your own markup. I'm going to show you what is a markup. L means language. So it's a language, so you have to follow the rules and create your own document. Let me go back again and redefine it. So X in the XML is extensible, means you can define language in the terms of whatever content you have in the mind. If you think of a student, then you can extend the language using the student first name, last name. If you think of a product, then you can extend the language using a product name and a product description, or whatever relevant to student or a product. It is up to you to decide how to extend the language. Everything you define in XML is made up of markup, and markup is a syntax of the language. A simple markup is something like this. You have an less than symbol, then the markup, then the closing tag, that's the greater than symbol, then some text, then a close-up of a markup. Right? So understand, everything that you write in XML, you write in this way. You don't write anything outside this one. So everything you define using a markup. So you write your own markups. The markup word that I have used, it can be defined as a last name, first name in context of student, a product name, a product description in terms if you're defining a product. L generally stands for language, which means it has a predefined rules that you have to follow. As I mentioned, everything has to be a markup. If you're writing outside it, then the language is not going to accept it. I hope the definition that I have shared is the easiest to remember. Never forget this picture, where also never forget what XML stands for, Extensible Markup Language. That's why I have highlighted X in the extensible, M in the markup and L in the language, just to show it's a full form of XML. Next, let's look at where it is used. Let's look at this picture. This picture actually talks about the purpose of XML. Let's imagine A on the left side and B on the right side are two physical systems. So A and B are two physical systems and they both want to communicate. So they want to exchange some data to communicate. Like how we both are communicating in English language, similarly system A and B wants to communicate. Then in order for A and B to communicate, system A stores the data in XML format and then transfer it over to system B. As system B is aware that system A is going to send the data in XML, it actually opens the XML document and read it and then understands it. Similarly, system B can pass over the different data using same XML format, and then system A actually understands what system B has sent over. This is how system A and system B can communicate with a common language, that is an XML language. Remember the main purpose of XML. XML is actually used to represent data and store it so that it can be referred later. I repeat, remember this definition. XML is to represent data. One more usage of XML is that many software applications heavily depend today on XML to save the data as a storage mechanism. You can even think it as a text file or a Word document which actually saves the data, or imagine XML as a container which holds the cookies. But really, XML is to represent the data. The only difference is that XML is a language based. So you need to follow some guidelines to save the data. As I discussed previously, you have to save the data in a markup language. The markups generally are used to represent the data that we store in the XML. So XML looks like something to do with storing of data and describing the data. Let's continue further. So let me clarify more about XML versus HTML. Did you heard of a HTML before? If not, then HTML actually used to write the web pages. Did you anytime try the source code behind the web pages that you browse every day? Well, that is written in HTML. HTML and XML are both markup language. That's the confusion, right? Because when you see how HTML is written, it's written using markup language. Even XML are written using markup language. So the confusion. But what is the difference between the both? Well, it's very simple. XML was designed to describe the data, and it focuses on what data is. Whereas HTML was designed to display the data and to focus on how data looks. So remember this simple definition whenever you want to differentiate between XML and HTML. XML is used to describe the data, wherein HTML is used to display the data. As I told previously, web pages are developed using HTML, which are displayed on the browser, but XML is used in the backend to read the data and process it. So let me summarize what we learned till here. So here is a summary of what we have discussed previously. First is the definition of XML. XML stands for Extensible Markup Language. And then we looked at difference between XML and HTML. XML and HTML both are markup language, but they are not same. XML is used to describe the data, wherein HTML is used to display the data. HTML has predefined rules, and XML we must define the rules. I use the word called tags. So in the next section we're going to look at what tags are. The XML main purpose is to store and transport the data. Well, that's all about XML. Simple to remember, right? Let's learn some new words in the XML language. Let me introduce three different terms that we use in XML. The first term is tag, second is element, and then is attribute. Let's look into each of it and understand where do we use it. The first keyword is tag. So when I say tag, I actually means some kind of text between less than and a greater than symbol. If you remember previously, we discussed about markup. Markup is a way we write XML. Everything in XML we write using markup. So now when we say tag, tag is similar to markup, right? So here onwards I'm just gonna say tag. I'm not gonna use markup as a term. A tag basically is a text which is between less than and greater than, and there are two different tags. First is that says there is a starting tag and there is an ending tag. So when you define a tag, you can choose any name inside it. As I said previously, if you're using for a student, you can use a last name, first name as a tag name, and if it's a product, you can use product name and a course description as a tag name. So here I'm showing you a starting tag and an ending tag. The starting tag, as I previously mentioned, it doesn't have a forward slash. It's the starting of a tag, then followed by some text, and then you end a starting tag with an ending tag. That's basically a language, right? That's basically a rule. Next, we talk about what is an element. An element is a starting tag, ending tag, and anything in between. So when you want to say name is an element, you're actually referring to name as a starting tag, some text, and name as an ending tag. So next time when I'm referring to element, Actually, I'm referring to the starting tag, text and ending tag. Next is an attribute. Generally, attribute is basically an additional parameters for the tag. It just enhances the behavior or explain the additional meaning of the tag. And an attribute is represented with a name and a value. Let's take an example. Let's say you have an element course and it has a starting course tag and an ending course tag, and level is equal to beginner is basically an attribute. So you can say level is an attribute for a course and the level value is beginner. So the course attribute level has a value called beginner. That's how you actually define it. So let me recap and use all the terms that we have used. So I'm showing you an sample XML. Let's try to define with the terms that we have used. The name has a starting tag and an ending tag, and PO cast is the data for the name. The course is an element, or course has a starting tag and course has an ending tag. Level is an attribute for course, and level has a value called beginner, which we can also say course has a level attribute with a value of beginner, and course has a value called introduction to XML. So that's how you actually define the whole XML. That's how you read the XML. Now let's look at how we structure the XML. Let's look at the structure of the XML. So let's start with the basics. Let's say when you open an XML, the first line that you should see in the XML is basically the XML declaration, which is mandatory for all the XMLs. So when you're writing an XML document, this is the line, like as I shown here, less than symbol, question mark XML version with a question mark and an ending with a greater than symbol. That should be the first line in the XML document. If you're not writing this line and then trying to directly write the tags, then the XML will error out, because that's the language specifications that you have to start with an XML notation. There are two different versions to it, right? First one is just the version as an attribute. The second one, you have an encoding as an attribute. And if you don't know what is an attribute, just refer back to the previous lessons. So let me walk you through what is this version and encoding talks about. Version is not the version management of your document. The version basically say, as an XML, the specification that is been written with XML is that version. It's not the version of the document. The encoding basically talks about the character set that is being used inside the XML. Let's say if you're writing a Japanese character, then you have to use a Japanese character set. The encoding set, you have to change it to a Japanese encoding, so that XML actually, when it renders the output or when someone wants to read it, they know what's the character set being used inside the XML. Okay, let's go and create one document using this notation. Let me give you an example of what we're going to define inside an XML. Think of an example of product listing. Let's say we want to define an XML for a product listing. The hierarchy that I'm showing you now is basically a product listing which has multiple products in it, and each product has multiple fields in it. So consider one product have name, description and price, and then we have multiple products in a product listing. So let me give you some new terminology here. Product listing is basically called as root element or a parent element, and product inside the product listing is called as child element. You can also call it as child of the parent or child of the root element. When a child has another child, like name, description and price are the child of product, the product generally becomes the parent for name, description and price. So it's a hierarchy wherein when you want to refer to a particular node, you actually see whether you have child nodes in it or have a parent node to it. So let's try to display this product listing and with a product with name in an XML file. Okay, so let's start mapping the fields that we have defined and with the data that we have. So left hand side you actually see the tags and tag names. The right hand side you see the data. So now if you really get this, so you're actually defining a fields on the left hand side and you are mapping out with the data. Let's take Microsoft Office as a product listing as an example, and inside Microsoft Office you have different products like Microsoft Word and Microsoft Excel. Microsoft Words can have different properties like name, description and price. The name could be word, the description would be word processing, and the price is some $99. So let's build an XML with these two things. One is a structure, which is a field name, and then the data inside that structure. Okay, let's start building a simple XML using the definition that I've shared previously. So let's try to show the product listing with the product and with its fields inside an XML file. So I'm going to generate the XML, then I'm going to show it in the Chrome browser. So first, let's understand how to write an XML. The first thing that you have to do is when you create an XML, let's say I'm trying to create an XML, right? The extension should be .xml. So let's say I create a product file. You can say it as a XML, right? So when you change file name to .xml, means when you display this file in the Chrome actually understands it to be an XML and it renders it to an XML format. Next up, I'm going to open this file and start writing the XML code. So first up, we're gonna say this is an XML with version 1.0. So one thing to remember that everything that you define in XML should start with this notation. Then we're going to define the product listing as we saw, and we can close the product listing. So this could be a parent tag, right? Then we're going to define a child tag to the product listing tag. So you can see here the product is a child of product listing and product listing is a root node or a parent node. Now we can define the product with its child fields. The first field is name, so we can say it is word. The second field is description. The third is price. And you can, once you save this file, you can double click this file to open, or you open the Chrome, right, and then you drag and drop this file. Okay, so if I have to run through this, what happened here? So Chrome actually used this extension to identify, or Chrome has already used this notation to identify this is an XML file, and then we try to render the output. Actually it knows which one is a parent and which one is a child. So this is a root node, then it has a child node of product, and the product has a fields called name, description and price. I hope that is a simple example of how to create an XML file. So I have walked you through an idea of how to define the notation that you have for a product listing and how to map it with the data, and then finally I have run through how to create the file and map out all those details together into an XML file. Hope now you can build your own XML files. So this diagram is similar to what we have learned previously about how to create the XML. It's just that to the parent node and to the child node I have added an attribute called title. As we learned about attribute generally provides an additional information about a tag. Now by adding the title to a product listing, we know what the product we're talking about. So product listing has a title of Microsoft Office, and then the product title actually have a Microsoft Word. So we know the product listing is about Microsoft Office and the product is about Microsoft Word. So when you have two products, now you can differentiate with the title. So that's the benefit of attribute. So attribute generally are small parameters or a property to a tag or to an element that you can define to differentiate between multiple repetitions of the product. So next up, we're going to learn about namespaces. So namespaces are generally used within XML document. And in terms, if you try to understand what is namespace in a programming language, namespaces are similar to folders. If you know a bit background of Java or .NET, you define packages in Java and then you define namespace in .NET. And it is when you come to the Windows, namespace are nothing but a folder. It's just a different container to say this is a container of namespace and I'm going to differentiate with a unique name to it, like a folder name. So let me give you an example of how we use namespace. So on the top, you have three different products. The first product have the same fields with the second product and the third product. The only differentiating between the three products are basically the data. If you look at the data here, you have the product and title, which is the same, and then there are different parameters to it. The first product has a color, the second product has a version, and the third product has a pages. But they are all three same products. And below you can see the complete listing of the XML document. The only thing is differentiation between the three different products is the first product is about clothes, the second product is about software, and the third product is about the books. Now the challenge is when you try to iterate or you try to want to get a value for a t-shirt or want to get a title, the problem that you're going to get when you try to read the property of a product. Let's say you want to read a property title for product of clothes, or you want to read a title for a product of software. Let's say you want to read the similar title for specific for books within the product. How you're gonna address it? Because they all have the same name, same hierarchy, and same parent. So that's where the namespace comes in. The namespace generally help you to identify uniquely each of this element. So you put them in a different namespace, means you define it as a different name and then you achieve it by accessing that name. Here's example I'm showing with the namespace. So there are two XML documents here. The left side is example without the namespace and the right hand side is an example with namespace. So let's say you have three different products. First product is about clothes, second is about software, and the third is about books. Now you want to access softwares, right, like Microsoft Office with the same product and title. So how you actually achieve that? So let me walk you through how you can actually define a namespace for a given XML and how you can differentiate those same names within the same XML. So there is an attribute called XML NS. NS stands for namespace. And with an XML NS colon, you can define any character there. You can define any name there. It's not a rule to have a constant there. The only rule is you have to define with an XML NS colon. And then you can give any URL there. That URL is again a custom build. You can give whatever URL you want to. So I have defined here three different URLs because I have three different categories. So with XML NS colon C, the C I'm representing is to as a clothes, and XML NS colon S I'm representing as tools, right, or softwares. The B, again the next one, I'm representing with books. So if I have to write down the products below, I actually use this namespace to differentiate between each of the product category. If I use a C category, C colon product, then I'm saying this is a category for clothes. And when I want to access clothes, I will refer C colon products, which will help me identify the products inside the category. And similarly, I can use the same notation to access software and access the books. So it's very clear that XML namespace provide a method to avoid element name conflicts. And this is a very important topic in XML. So if you don't understand this, I recommend you to go back, reread it and try to understand what's the concept behind it. It's very simple to understand. Next up, we're going to see when you write an XML, is it well formatted or it has any errors? Is it valid or an invalid XML? So first we're going to look how to format the XML. Means not formatting in the sense aligning the XML, but to check whether XML is well formatted. Because we understood that XML is predefined language, means it follows some kind of specifications and it has some rules, then we have to identify whether our XML that we have defined has others to that rules or not. So it's actually called as well formatted. So any XML that you write, you can actually use some online tools, or you can just view it in a browser to see whether the XML is well formatted or not. So I'm using an online tool called www.utilities-online.info/XST validation. I'm going to talk about what is XST, but use this tool to check what is XML well formatted first. So I've pasted an XML file there in the XML box, and then when I click on check XML well formatted, it actually validates whether the XML is well formatted. Now everything is okay, so it says XML is well formatted. But imagine I change up something. Let's say name, I have changed the case, and now when I check for well formatted, because XML is case sensitive, so you cannot have different cases from starting to ending tag or anywhere in the tags or the elements. So you need to follow that. That's basically to say that XML is formatted or not. You can even play around with this. Let's say when you're writing this XML, you have forgot to write the ending tag. So what's going to happen? Because this kind of errors are very common errors. So when you define an XML, you generally open this kind of tools, and before publishing those XMLs, you copy it over here and then you check whether it is well formatted or not. So let me do a check here. So here it's saying the price has never been closed. This is a cool feature, right? Yeah. So whenever you write an XML, make sure it is well formatted and it has been tested with any of the online tools, or you can directly open a browser to see whether the XML is well formatted or not. Okay, we have seen what is XML well formatted. Now let's look into what is an valid and an invalid XML. When you write an XML, right, you can actually predefine some set of rules to say, which is a custom rules, right? The formatted, we understood that you're checking against the XML's rules, like missing tags, case sensitive. How about defining a custom rules on top of the existing rules and then validating the XML based on those rules? And when those rules are not met, you want to say that XML document is an invalid document. So I want to bring you a new concept called XSD, which is XML schema definition, which is a recommendation that specifies how to formally describe the element in an extensible markup language. It's an XML document. So it defines the rules on how the data should be displayed and how many times the fields has to be iterated inside the structure. The example that I'm showing you on the left hand side basically is an XSD document. I'm not going to go through everything inside the XSD. I'm going to start explaining it because there is a section completely on XSD and ETD where I'm going to show you what is XSD, what's the definition of it, how to write it, what is the structure and all those things. But here I just want to bring you a point that you can define a custom definition and then you can validate those custom definition against the XML to say whether the XML is valid or invalid. So I've defined a XSD, you can think as a rules file called as product.xsd, and then I have the XML file which defines the XML. And in the rules file, I have said that the price has to be integer. Whenever you write an XML document and you want to validate those XML based on the custom rules that you have defined, you can match up whether that price field is integer or not. If that price field does not match with the custom rule, then XML is not validated and XML is invalid. So when the rules that has been defined is being validated against the XML document and XML document does not follow that rule, then we call that XML document as an invalid document. So let me show you a live example of how it is validated and invalidated. Now let's look at the example of how do you validate the XML against an XSD. I'm again going to the same site wherein I have pasted the XML document on the left hand side and the XSD document on the right hand side. So as of now, if you don't understand what is XSD, XST is a rules file. You define rules inside on how the data and the structure should be defined inside the XML. There are a couple of things that we need to check. The first is you check whether XML is well formatted, right? This is what we learned in previous lesson. You can even check whether the XSD is validated. It is similar to well formatted. The second thing, there's another option where you can check whether XML is validated against the XSD. If you just quite run through it, you will know that I have defined an element of price of type integer. I have said that the price field should be of type integer. But what I have done is I have not defined the price as integer, and actually I have defined it as a string. So when I want to validate this XML against this XSD, I should get some error saying that this price does not follow the rule that you have defined. Okay, let's look up what's the result say so. Okay, so the results say the same thing. This $99 is not valid for integer and element price is not valid. So you can do two things here. You can change the price here to say to represent integer, or you can change the data type in the XSD to say it's a string, and it could be a price string or it could be an integer string, right? So let's take the first approach. Let's try to change this and see what's going to happen. Let's say I'm going to push back 99 as an price, and I'm again validating it. This time it is well formatted and valid. So well formatted, as I explained, is a structure. XSD validation is a structure. Then you can validate an XML against an XSD, which is nothing but validating the rules against your XML. By now you should have pretty much a good idea about XML, how to define an XML, and how the XML language has been defined with different elements, tags, and attributes. So we have seen a couple of things in this podcast. I just want to summarize this. First, we have looked at what is XML. We have defined what XML definition is, and then we have defined element, attribute, and tag. Then we have looked at different hierarchy levels of an XML. What is a parent tag? What is a child tag? And then we have looked at a sample notation of product listing, and then we have created an XML based on the sample notation. Then we have added some attributes to our XML, and after that we have validated and formatted our XML. After that we have validated our XML against XSD, and then we have checked whether the XML is formatted or not. So all these basics basically help you to start with XML. Why is this important? Just to give you a background, within the PO, the message processing happens using the XML language. So it's important to understand and learn it, because when you do an interface, you're going to validate the XML against the XSD. Sometimes you have to check whether the XML is well formatted or not. These are part of the configuration though, but still you have to understand from the ground up how it has been done. I hope you have learned something important out of this podcast. Thanks for listening, and visit us at pocast.com. Until then, have a good day and see you later. Bye.